So lesson 7 is about organic chemistry. So organic chemistry is the study of chemistry related to living things. Central to organic chemistry is any compound that has carbon in it. So specifically, we're going to talk about hydrocarbons today. And just to, take notes here, draw some pictures. The big thing you want to be able to get out of this is given a picture of a hydrocarbon. Could you tell me its name? Could you tell me, is it double bonded, triple bonded? Does it have, an alcohol group on it? That sort of thing. All right, so there's a lot of classification and pattern recognition going on here. So, just kind of breaking that word down, hydrocarbon. What do you think is in a hydrocarbon? If you were thinking hydrogen and carbon, you were exactly correct. All right, so hydrocarbons will always have carbons and hydrogens in them. As we continue, we'll talk about what other things might be there, but at the minimum, they have to have carbon and hydrogen to be considered a hydrocarbon. So we've got some first kind of classification thing is basic types of hydrocarbons. All right, and these are ones that have only hydrogen and carbon in them. All right, and they can get classified in a couple of different ways. They are saturated, which means they have the maximum amount of hydrogens possible. All right, no multiple bonds. Or they might be unsaturated, which means they do have multiple bonds, and there's carbons that have been removed in order to make room for those bonds. All right, because if you look at this first one, the very first alkane, all right, you can see that there are 6 hydrogens, and then between the 2 carbons, there's just this single bond. All right, whereas to go to this next one, the alkene, we had to remove 2 hydrogens in order to make room for that double bond. All right, and if you go to an alkyne, which has a triple bond in there, you have to remove 2 more. All right, or 4 total from that original alkane to get the triple bond. All right, so as things have double or triple bonds, we call them unsaturated because there's room for more hydrogens there. They just have been replaced by an extra bond between the carbons. All right, so these guys over here on the left are what we call straight chain hydrocarbons. All right, and these ones on the left are what we call cyclic or circular hydrocarbons. All right, so cyclic hydrocarbons, if they are saturated, they're just called cyclic. All right, if they are unsaturated, we call them aromatic. Okay, so definitely I'm going to erase some stuff here so that you can have a good view of the pictures. All right, but definitely know how to recognize something as an alkene, an alkyne, a cyclic hydrocarbon. What are those key components that fall into that category? All right, so alkenes have double bonds, alkynes have triple bonds. Aromatic are going to be circular with multiple bonds. All right. Then see if you can identify what type of hydrocarbon is present in these pictures. All right, so I'd say pause the video here, see if you can get it right. All right, I'm not going to do every single one, but I'll do 4 or 5 of them. So like this first one is all single bonds, so it's going to be an alkane. This is a cyclic alkane or hydrocarbon, because it's got a circle there. Let's see, here's an alkene, because it's got a double bond. Let's find, here's an alkyne with a triple bond. All right, here's an aromatic hydrocarbon, because it has cyclic features, but there's double bonds in there. Hydrocarbon. All right, here's another alkene because of a double bond. There's another alkane. All right, so if this seems really easy, great. If it doesn't, talk to me, because we definitely need to get you familiar with just recognizing the differences between these types of hydrocarbons. When it comes to naming hydrocarbons, all right, the only ones that you're going to be required to know how to name correctly are going to be just your basic hydrocarbons. All right, and how you name them is based on the length of their chain. All right, so if it has one carbon, it gets a prefix meth for 1, eth for 2, prop for 3, bute for 4, pent for 5, hex for 6, hept for 7, oct for 8, non for 9, and dec for 10. All right, so if this, especially ones like these that don't match anything that we've seen in like geometry class, you might need to write those down. All right, but it's, you have the number prefix, all right, and then the suffix tells you the type of hydrocarbon. All right, so like alkanes always end in ane. So first, just practice the whole number thing. We've got 1, 2, 3, 4. So this is butane. 1, 2, 3, propane. 1, 2, 3, 4, 5, 6. That makes this hexane. Oops. Cannot write today. And 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be nonane. All right. So the ending of the word will change based on what type of hydrocarbon you're working with. All right. So actually, I'm noticing there's some missing hydrogens here. All right, so propane has your 3 carbons. All right, propene also has 3 carbons, but this ene ending signifies that there's a double bond in there. And then propyne also has 3 carbons, but the yne ending is for triple bonds. So ane, single bond. Ene, double bond. Ine, triple. Okay? So, see if you can name the following. All right? So, for example, here we've got 2 carbons. All right? So, that's going to make it eth. And then the ending has to match the fact that I have a double bond. So this will be ethene for the double bond. All right. This one in the middle here, we've got 1, 2, 3, 4, 5, 6, 7. So sept. And then it's all single bonds, so it'll be septane. All right. This one up top here, we've got 1, 2, 3, 4. Prefix for 4 is bute. And then there's a triple bond in here, so it's butyne. All right, do one more. Got 1, 2, 3. So that's going to be prop. And then there's a double bond, so it's going to be ene. All right. So again, hopefully this seems easy. If it doesn't, talk to me. All right. The last thing, and this is probably the trickiest part, I would honestly take a screenshot of this, use this as a cheat sheet. All right. I don't need you to necessarily have all of this memorized, but I want you to, look at a chemical, and if you see that somewhere in its structure, I want you to be able to say, oh, that's an amide. All right. So just to kind of break down what this stuff is showing you on here. All right. The following are functional groups, so they're going to be something kind of like somewhere in the hydrocarbon. They don't have to be necessarily on the end or in the middle. They could, for most part, these can be anywhere on them. And then where these little blue dots are means that the hydrocarbon, the chemical itself, can continue beyond. All right, so this is just showing you a portion of what's there. All right. So again, this is all about pattern recognition. All right. So let's see. We know alkane, alkene, and alkyne. So an ether, all right, is known for having an oxygen that's sandwiched between two carbons, and everything is single bonded. Whereas an ester has that oxygen sandwiched between two carbons, but one of those carbons has a double bonded oxygen on it. All right, so you've got to have this O, C, O, C in there, in that like direct connection. An alkyl halide, so this X can be any halogen. All right, so that could be chlorine, it could be bromine, it could be iodine, it could be fluorine, all right, any halogen. All right, so if you see a halogen attached to your hydrocarbon somewhere, then we would call that an alkyl halide. An amine is going to have a nitrogen attached to it. All right, now there are ways of talking about this. This doesn't necessarily have to be NH2. It just needs to have nitrogen and only nitrogen. Alcohol has an OH group on it. All right. Phenyl means that, there's going to be a longer chain that goes on off of this. So a phenyl is like a aromatic hydrocarbon attached to something else, a much longer, like straight chain hydrocarbon. Amide and amide, you'll notice, are kind of similar to each other. Again, the big difference is that instead of just having the nitrogen, an amide is going to have the nitrogen, and the carbon that it's attached to is also going to be double bonded to an oxygen. All right, so aldehyde and ketone, these guys are really, really similar. All right, the kind of defining feature is a double bonded oxygen. The trick is an aldehyde has to be at the end of the chain. All right, so that's why instead of having a little blue dot here, we have an H there. This is always going to be the edge, the very end of a chain, whereas a ketone has to be in the middle of the chain. All right, so on both sides, there's going to be other things attached that's not a hydrogen. And then a carboxylic acid is kind of like a cross between a ketone and an alcohol. So that on the same carbon, you're going to have an OH group and a double bonded oxygen. All right, so again, I'm going to don't know why erasing's not working. There we go. I'm going to erase some of this stuff so that you can have a nice clear picture. But screenshot this. All right, and use it when you're looking at chemical compounds. You might see is something like this. All right, label the following based on their functional group. All right. So let's see. This one here, I've got O, attached to carbons on each side. So it's like this. So that's an ether. All right. Here I've got an OH group on carbon and hydrogen, so this is going to be an alcohol. This molecule here, the way it's written, it's kind of hard to see the shape, but I want you to know that the COOH, what that means is you have this. All right, this is just a shorthand way of writing out a carboxylic acid without having to draw the actual structure. All right, so really what this chemical looks like, oops, I didn't mean to do that, but, all right, is you've got your carbon attached to double bonded oxygen in an alcohol group. All right, so COOH means carboxylic acid, or this structure right there. All right, so next one, I have a double bonded oxygen here, and it's in the middle of the chain because these are both carbons. So that makes this a ketone. All right, here I have a double bonded oxygen, but it's attached, at least on one side, to an H, which means it's at the end of the chain. So that makes this an aldehyde. And last one, we've got carbon, carbon, and an OH group. So this is another alcohol. So the trickier part probably is this last one, just because there's so many different options for those functional groups. So if you need some more practice, just let me know. We can look at tons of different pictures and work on making sure you know how to pick out those functional groups.